Okay, so let's get started. Today we will be continuing talking a little bit about loops and seeing some other couple of nuances of loops. And then we'll get started on our first algorithm, the Geuss-and-check algorithm. And then towards the end, we're going to start talking about binary numbers in advance of seeing our next algorithm. So let's do a quick recap of what we learned last time, and then we'll do a little coding example, and then we'll move on. So we saw last lecture some looping mechanisms, right? We saw while loops and for loops. They were both a way for us to control what happens in the code, and specifically, they're a way for us to repeat certain lines in the code sort of automatically, so to speak. So with while loops, the lines of code were repeated as long as some condition held. And with for loops, the lines of code were repeated for some sequence of values. Okay? And the sequence of values was something that we decided. It was numerical. That's what we saw last lecture. Today we're going to see that the sequence of values can actually be non-numerical as well. So both of those loop types, I guess, ended at certain times, right? So the while loop ended when the condition became false, and the for loop ended when we've exhausted our sequence of values. But oftentimes we want to write programs where we break out of the loop prematurely. We don't want the while loop condition to become false, and we don't want to exhaust our entire set of values in a for loop. So in order to exit a loop before the natural end comes, we can use this thing called a break statement. And the break statement allows us to exit the loop, and the loop it exits is going to be the one that immediately surrounds the break statement. So here's a little example of two nested while loops, so one while loop and then one nested one inside it. The outer one is going to run whenever condition 1 holds, and the inner one runs whenever condition 2 holds. Okay? Now, expression A will evaluate when both condition 1 and condition 2 hold, right? So we enter the first while loop and we enter the second while loop. Both of those conditions have to be true. But Python, as soon as it sees this break statement, Python will immediately exit the loop that surrounds that break statement. So the loop that surrounds the break statement is the one that has condition 2, right? The condition 1 loop will keep going. So as soon as Python sees this break statement, it's going to immediately stop running the while loop. It's not even going to go back up and check the condition 2, which means that expression B will actually never get evaluated. So this is terrible code. We don't want to write code like this because expression B will never be run, right? But this is just to show you the impact that a break statement would have. And expression C will then be evaluated whenever condition 1 is true. Now, condition 2 may or may not have been true along the way, but expression C will evaluate only when condition 1 is true, right? Condition 2 would have stopped being true, and then we're going at the same indentation level as this inner while loop.
So it it only evaluates the one time, like it only gives A ones, and then because the break is there?
Exactly, yeah, that's a great point. So it only evaluates this expression A one time, because right after it evaluates it, it sees the break, and then we immediately exit the while loop and we're done. That is a great observation, yeah. And that's what this code will basically show. So here it is, us doing the break statement sort of in the same structure as on the previous slide. And what we're going to do is actually just run the Python tutor for this code, just to give you some more practice running the Python tutor. So this is the same code as on the previous slide. I've got a for loop that goes through a sequence of values. Can anyone tell me what are the sequence of values this for loop will loop over? 5, 7, 9, and we stop, right? Because 11 is end, but we go up to but not including n minus 1. So 5, 7, 9 are the only 3 values we would potentially loop over. So hit next, we initialize MySum to 0. So in our minds, we kind of think about the fact that we're going to loop through, make this loop variable be 5, 7, 9. So the first time through the loop, I will be 5. We're going to add I, which is currently 5, to MySum. So 5 plus 0 makes MySum 5. And then we immediately see the break. right? Because if my sum equals 5 is true, so we go inside and we immediately see the break statement. This line will never get executed, so we're never going to increment my sum by 1. So the break immediately breaks out of our loop. Now the if statement is not a loop, right? It's a conditional, so the loop we break out of is the for loop. And then there's no other loop surrounding it, so then the program is basically done and we print 5. Okay. Again, bad code. We would never write code like this, but this is just to show you exactly what happens with a break statement. All right, so there's the code block for the for loop, and this is the code block for the if statement. And the break breaks out of our loop, right, which is the lighter purple, not the if statement. Okay, so let's have you write a little bit of code, and this is sort of maybe a little practice with just loops in general that we saw last lecture. There's no break really in this particular program here, just a little bit of practice. So what I want you to do is to write code that basically has a for loop running through this range, so for I in, pick one of these. I want you to write code within that for loop that counts
There's no break,
how many
really, in
how
this
many
particular
even numbers
program
are in that
here.
range, right? So including the 0. So for range 5, your counter should basically pick up on the fact that 0 is even, 2 is even, and 4 is even, and then that's it. So it should print 3. So here is the you try it inside the Python file for today. And I've already started you off with this for I in range 5 as the first one. And I'll give you a couple minutes to just write the code in here. Okay. Would anyone like to start us off with some code? Or give me, yeah. Yep. So this line of code is going to take our I, right? So in fact, what we could do to remind ourselves what I is, and this is very helpful for quizzes as well, we can write a little comment here that says I is 0, 1, 2, 3, 4, just so we don't have to remember this fact. We can just always look here and know what I is going to be. And then this line of code, absolutely correct, is going to take I and grab the remainder when I is divided by 2. Okay? And if the remainder is 0, that means that the number is even. And then what do we do inside here? So when this is true, when it's even, how do we keep track of whether or how many times this condition occurs? Yeah. Yes, exactly. Should we create a variable? Yes, we can. So let's call it even nums. And we'll probably want to increment it by 1, right? Because here's another number that's even. So even nums plus equals 1. And then let's remember to initialize it right before our loop, right? So initially, before we even start our loop, we have 0 even numbers. And then each time through our loop, we see one that's perfectly divisible by 2. We're going to increment this little counter by 1. Okay? And,
Not the same variable?
oh yeah, not the same variable, thank you. Even nums, yeah. And the mental model you should have sort of at this point or be getting is just the fact that these 3 lines solve our problem. It does the automatic counting for us, right? Because I will take on 0, then 1, then 2, then 3, and then 4 automatically as the loop goes through this sequence of values. And so at the end of the loop, so sort of at the same indentation level as the for loop, all we need to do is print how many of these numbers we have. So if we run it, it'll print 3. And if we change this to 10, it'll print probably 6, right? Because it counts the 0, right? Questions about, yeah, please.
Is there anything I should look out for if mine prints out 2 instead of 3?
So if you're undercounting, you maybe did you initialize even nums to something else? Or maybe this is not incrementing right, or maybe the range is different?
I'll try the range of 2.
Yeah. It worked? Awesome. Okay. So iterating through, using for loops to iterate through sequence of values is pretty useful. Let's take another look here at this particular program. So this program is this set of code, this code, and this code actually end up doing the same thing. But let's look at the top one for now. So this is a program that takes in a string s as sort of an input, so to speak. It iterates through the numbers 0 to the length of s, right? So for index in range len s is basically going to say for index in range 13 or however many letters this string has, right? D, E, M, O, space, L, O, like all those letters, there's probably 13 of them or something like that. So this line of code here is going to have our index take on the values 0 through 13, representing the index in S, right? So the lowercase d will be at index 0, the lowercase e will be at index 1, and so on. So with this index in hand, the next bit of code, if s square bracket index equal I, will check for me if this particular character is an I, or that particular character is a U. And every time that happens, I'm going to have this print out to the screen. There's an I or a U. So inside my code here, this is the first one, and I run it, it's going to print out that sentence twice because there's only 2 I's or U's in here, and if it repeats, it'll print it out twice. So there's 1 U and 1 I. Okay. But this code can actually be written a lot simpler. Okay? Notice it took me a little bit of a while to explain it, and probably at first glance, it would take you a little bit of time to figure out what it's doing. And that's because we're actually relying on the index as kind of a middleman, right? We're iterating our for loop through the index, and then we're indexing into that index variable to grab the particular letter. It turns out that with for loops, right, I told you can iterate over any sequence of values, not just numbers. And remember that strings are actually just a sequence of characters, right? Case-sensitive characters. So in Python, we can actually write code like this. So the middle box right here. It has our for loop iterating through each character in the string directly. So no longer are we looking at the index, 0 through 12, but we're looking at the letter directly. So our loop variable, which I called char, but you can call whatever you'd like, is now going to take on values that are the letters themselves, one at a time. So the first time through the loop, char will be lowercase d. The next time through the loop, char will be lowercase e. The next time, char will be lowercase m, and so on. And so now we've got this sequence of values that's the letters directly. So when we check if the letter is an I or a U, all I need to do is check if that character, right, char, my variable, is equivalent to I or equivalent to U. And it's going to be the same, and it's exactly the same code. So this is the one we had before, and this is the one I just went through. And again, it prints out that sentence twice, right, because it's the same starting string. So the sequence of values now is our characters direct, right? It's the letters directly. It's not the index itself. And it turns out there's actually a much more Pythonic way to write the code, this middle box down here. So in the bottom box, the only part that I've changed is the if statement. And I'm using this in keyword to test whether the character that I have in hand, lowercase d, lowercase e, lowercase m, and so on, is in this sequence of characters, I or U. And for this case, it's not so important, right? Because in the middle box, we could do if char is equal to I or char is equal to U, which is fine. But if we wanted to test if the character is one of the digits 0 through 9, this if, or would become a really long line, right? And so all we can do is, if char is in some particular sequence of characters, Python will automatically turn that into that longer if it's this, or if it's this, or if it's this, or if it's this, and so on. Okay. Okay, so the big idea here with for loops is that, yes, we're iterating through a sequence of values, but we're not limited to just numbers. And that's the cool thing about for loops. You can iterate through characters directly, and we're going to see later on we can iterate through lists of numbers, lists of strings, and a whole bunch of other things. So let's write a slightly more complex program. This was version 0.01 of the cheerleader robots. You see up in the corner there that I wrote. The robots are not mine, but the code is. So here's a little bit of code that kind of puts together iterating through strings directly and iterating through numbers directly. So let me show you what this program is actually doing, and then we'll go over the code. Somebody give me some noun you're really excited about. What is that? Business. What? Never mind. Give me something else that I know. What is it? Pineapples. Okay. Pineapples. Okay, so it's going to cheer for us about pineapples, and let's say we're enthusiastic level 8 about pineapples. All right, so this is my cheerleader program. So I typed in a word, and I typed in an enthusiasm level for pineapples. And then all it does is, and notice the repetition, which computers are really awesome for. Give me a P, give me an I, give me an N, and so on, right? What does that spell? And then it does pineapples with 3 exclamation marks 8 times, because that's how enthusiastic I'm about pineapples. All right, so let's look at the code that actually does this. Notice there's 2 parts to it, right? There's the part that does the spelling, and then there's the part that does repeating the word some number of times. So these are 2 separate loops. The spelling is up here, this for loop here, and then repeating some number of times is down here. Okay, so the part where we do the spelling has a for loop that iterates through the letters in the word directly, right? I'm not doing anything special with these letters, so I can just iterate through the letters directly. So for W in word, where word is the input that I grabbed from the user, W is a loop variable that's going to first be P, then I, then N, then E, then A, and so on, right? And then I have an if-else here, and if you look carefully, the only difference between the if, what we do inside the if and what we do inside the else is whether we type in un and then a letter, or a and then the letter, right? Because some letters make sense to say, give me un a, as opposed to give me a. It just doesn't sound right in English. The letters, where it makes sense to do un, are defined up here. So notice they're just defined as a really long string. And so the if statement uses that in keyword we saw on the slide, right? It says if W, so if that particular character is one of these, is in this sequence of characters, then print give me un and that particular character. And otherwise, it's not one of these letters where it makes sense to say un, so then you just print give me a and then that letter. Here, I just rewrote these 2 print statements using f strings, which we talked about back in lecture 2, just to show you how you could rewrite it with f strings, but it can be done both ways. Okay, so at the end of this, we've done the spelling, and then we have a print statement that says, what does that spell? And then the last part is to repeat that word some n number of times, whatever the user told us. So I saved that number of times in a variable called times, and then all I do here is I have a nice little for loop that goes through how much that number is, right? So range times means it's going to be 0 all all the way up through and including times minus 1. That's a total of eight times in this particular case that it loops through, and then all we do is print the word with 3 exclamation marks. Notice that this print statement that's inside the bottom for loop is not actually doing anything with our loop variable, right? Our loop variable here is I, but we're not doing anything with it. And that's totally fine, right? Because all we're using in the times in the loop variable in this particular case is to do this action some number of times, right? We don't always have to do something with that loop variable. Any questions about this code? Yeah.
Could you also have used if statements for the print?
Could you use if statements for the prints? Which prints? These ones?
Yeah.
How so?
I mean, to evaluate like the W's instead of having to concatenate things. I mean F, not if, F.
Oh, F strings. Yeah, we could have done it like this. Yeah, so this is how it is F, and then we do the characters themselves inside the curly brackets. Yeah. Oh no, that's okay. It's okay. Yeah, there's a question. Yeah.
Can you explain how that last for loop works since we're not actually doing it on I?
Yeah. So the last for loop is still going to iterate through times, right? And the loop variable each time through the loop will be 0, then 1, then 2, then 3. We're not doing anything with the I, right? The stuff that's indented is going to get done, but we're just not using the fact that I is 0 or 1 or 2 at all.
But it'll increment itself.
Yeah, it increments itself automatically. We're just not using it. Yeah, exactly. Okay. And that's what I said. Okay, so let's have you write a little bit of code. So let's assume you're going to be given a string of lowercase letters, right? So we're not going to bother uppercase, lowercase, just assume you're given lowercase letters. It's stored in a variable s, so as an example, s is equal to ABCA. I would like you to write some code that counts how many unique letters are in this string, right? So notice A occurs twice, but the count that your code should do for this particular in this particular string should just be 3, right? We don't want to double count the A. So there are 3 unique letters in ABCA. They are A, B, and C. So I do have a little hint. It involves the use of an extra variable, as these programs usually go. Try to think about having this extra variable be a string that contains everything you've seen so far. So as soon as you see a letter that you haven't seen before, add it to this string variable that marking that you've now seen this letter, and then use this seen variable to write the rest of it. So as you go through your letters, make sure that you're going to check whether you've seen it already before recounting it. So as usual, it's in here around line 76. This is the code to do it. So I'll give you a couple minutes and then we can write it together. Okay. So let me just work through it. And this is something that I think is pretty useful in a quiz situation. It's just writing things on paper first. Just because it's a programming and computer science class doesn't mean we have to start coding right away. So it's really helpful to just kind of put some ideas down on paper. So the way I would go about this problem is, clearly I have to touch each character, right, in the string S. So already for me, I need to have a loop. So as I'm looking at each character, I'm going to keep track of it. So if it's not something I haven't seen, if it's something I haven't seen before, what I want to do is say, okay, I have now seen this A. So I'm going to add it to a seen variable. And then I'm going to increment a counter, right? I've seen it once. So count maybe equals 1 now. The next time I look at the next letter, I'm going to say, it's a B. Have I seen it before? No. Let me add it to my seen variable and increment my count. Next time, I'm going to look at the letter C. Have I seen it before? No. I'm going to add it to my seen, and then I'm going to increment my count. And then the last time I'm going to look at this letter A, I'm going to say, is it already in my seen? Yep. So I'm not going to do anything with this one, right? So when I see a letter that's already seen, that I've already added to my seen variable, I basically do nothing in my code, right? So most of the work happens when I encounter something I have never seen before. So does anyone have some starter code or something we can write? We don't have to write it perfectly top to bottom. We can write pieces here and there. Yeah.
So after like you define your things up there.
Yep.
I wrote for car and S. And I don't think this is how courseware write it, but I said like if car and S in scene equals false, but like I want to say if it's not in scene.
Yeah, so that's a great start. So if you want to say if it's not in scene, we can just say if char or car, however you pronounce it, is not in scene. So that takes the inverse of, true or false, whatever this is, right? Because in scene will either be true or false, and not that will be false or true, right? So that's perfect. Yeah.
Can you quickly, when do we use the word not and when do we use like the exclamation point?
Oh, yeah. So we can use not when we're dealing with Booleans, right? So an expression that evaluates to true or false. That's when we use not. And the not equal, so the exclamation mark equal, is used with other expressions when we're testing for equality, right? Like 3 not equal 2, or like A not equal B, or something like that, right? So things that could be numerical, not necessarily just true and false. Yeah. Okay. So if char is not in scene, so if I haven't seen it before, what do I want to do? Yeah. Yep. Yep. So we can append the character that we just looked at to our scene list, right? Just as we had done incrementally here. So that takes care of adding the character one by one if we haven't seen it to our scene. Good? Anything else we want to do? Or we can even test it out like this, right? So we can print scene each time through our loop. Right? So first it's A, then it's AB, then it's ABC, and then the last time it should still be ABC, and it is. Okay? And the last step is to just do what the problem asks us to do, which is to print how many characters or how many unique characters are in this list, or in this string. Yep. Yeah, we can have a counter that is initially 0 before the loop, and every time we add a new thing to our scene string, we can increment our counter, and then that takes care of the bulk of the work, right? This does all the counting, all the adding to the unique scene, and so at the end of the loop, we have this number in hand, and then we can just print it. So with this particular case, it's 3. If we add more A's in random spots, it's still going to be 3, right? Yeah.
Now to the
Yeah, so now that we have some code that basically works really well, we can make improvements to it. So one improvement that's suggested is instead of keeping a counter variable, we can actually just recognize the fact that the length of our scene is just all the unique characters we've seen already, right? Because when we double up on something, we don't re-add it. So all we can do to print out the number of unique characters is to just say, I'm going to print out the length of scene. Okay? And now there's no need to increment any sort of counter. And so that still gives us 3. Questions about this code? Does it make sense? Okay. Notice there's no else, right? We just have a nice little if. There's no else because there's nothing to do when we've already seen the character. So we could have else pass. And pass is just it's just a keyword in Python. You see it's turned blue because it's a keyword in Python. It just means do nothing, right? So we wouldn't write this, obviously, but that's, if we had an else case, that's what we would do, we would just do nothing. Okay. Other questions about the code? Is that right? Sorry, say again? Why are we printing the length of scene here? So we're printing the length of scene because we see that whenever we add a unique character to this scene variable, it's one that we haven't actually seen before, right? And so the